first slide, basic definitions. We have to learn about two basic definitions before everything, right? So the first one is about a a term called methodology, and the second one is called method, right? Method versus methodologies. We can even tell like that, right? So method. So what is method here? So method. So I'm going to start with the method for a reason, right? Okay. So method is a set of procedures in which a specific goal is approached step by step. Okay. So if this is confusing you, I'm going to tell you what method is. Example, we can say making a tea, right? Making a tea. So this is what our requirement, right? So the making a tea is going to consist of steps, right? So we can say step 1, step 2, step 3, and step 4, right? So we can say step 1 is what? Boil the water. Boil water. So the water is boiling. Second one, after the water is boiled, we are going to add some tea. Okay, we are going to add some tea or tea powder or whatever, right? So in the step number 3, we are going to add some sugar. Add some sugar, right? So after adding the sugar, finally we will going to serve the tea. We are going to serve the tea for whoever they are, right? So this is what this is consist of some steps, right? Consist of some step. So actually this collection of steps are called as method. Collection of steps are called as method here. Now take a look of the definition. A method is a set of procedures. So here, set of procedure, right? So set of procedure mean this is what the set of procedure here. What is that one? So step 1 is one procedure. This is second procedure. This is third procedure. And this is our fourth procedure to make a tea. Okay, so a method is a set of procedure in which a specific goal is approached step by step. What is the specific goal here? Making a tea, right? This is what our ultimate goal, right? To achieve this goal, there is a set of procedure, right? So that set of procedure uh, to achieve a specific goal is called what? Method, right? So the next one is about methodology, right? That's about the method. And now we are going to learn about methodologies, right? So methodology, actually, we can call it as explain as a science of methods. Science of methods, right? So normally this methodology, so I'm going to explain what is methodology here. So before that, this methodology going to give you answer for some of the question. So we can say it answers first one is going to answer which method should we use. Which method should we use? This question will be answered by the methodology. Okay. Second one, why should it be used? Why that specific method is used, right? Why it be used? Okay. Third one. So third one is about when should it be used? So which, why, and when, right? When should it be used? So all those things, right? So which method, why that method, and when that method, right? All of these questions are going to be answered by the methodology, right? So what is this methodology is? Methodology is the explain as a science of the methods, right? So whatever the method we are using, regarding that method, we are going to explain using the methodology. Okay. For an example, let's say a lecturer, right? Normally, a lecturer, lecturer. So there are, if a lecturer, he is having maybe different methodologies, like methods, right? For an example, he may have a method called lecture method, right? Lecture method, right? And he may have another method called discussion method. And third one, he may have a method called demonstration method, right? So just imagine if a lecturer want to choose which method he is going to use is based on the situation, right? If he is doing a lecture, he will do the lecture method. If he is doing some practical session, the lecture method is not that much of important there. He have to use the demonstration method to explain the practical, right? Discussion method. So he or she, if she or he is talking with the student regarding the final exam or paper structure or something, that time the lecture method or demonstration method is not useful. In that time, she or he need to use the discussion method, right? So like how based on the situation, we are going to choose which method should be used in that situation to fulfill the requirement, right? Likewise, uh, the actual definition for the methodology now is to, we can say like this, a methodology, right? A methodology is actually choose and organize the actual method. Choose and organize the actual method is called as methodology. So choose and organize the method is called as methodology, right? It's called as methodology, right? So I'm going to give you some further example as well, which is related to the software or else software engineering, right? So imagine I'm going to list some method here, some methods. For an example, methods are one I can see identify requirements, identify the requirements, then design, design, then code, then finally test. Okay, so these are, you all know these are methods. So can someone tell me what these methods are belongs to, what type of methods, why we are using these methods? Okay. Okay, yeah, I'm still explaining the methodology. I did not complete the methodology explanation. Even if you didn't get the clear understanding of the methodology, you can even follow this one, right? Even from this example also, you can be able to understand the methodologies, right? Okay, so I will tell you. Right. So these are actually, I just listed some methods here. One is called identify the requirement. Second one is design. Third one is code. And fourth one is test. Actually, these are the methods. These are the actual, if it is a method, what is methods mean? Steps of, right, collection of, what's it saying in the slide? Method is actually a set of procedure in which a specific goal is approached, right? So step one, all the steps, step two, step three, step four, these all the steps are for the specific goal, making a T. Likewise, these methods identify the requirement, design, code, test. This is what? This is actually a SDLC, you know, system development or a software development life cycle, right? Normally, if we are going to design a software, first thing we are going to identify the requirement. Then we are going to do the designing part, right? Then coding, then testing, right? So in between the coding and testing, or else after testing, there is something called maintenance, right? So just I'm saying these are some steps that is related to the SDLC, right? So all these steps are, we can proudly say, these are methods, right? Methods. What the methodology now? Methodology. So, right. So can someone tell me, to achieve this method, right? What is the ultimate goal? Ultimate goal is the SDLC, so software development life cycles. For the software development life cycle, steps are identify requirement, design, code, and finally test. For the SDLC, what are the methodologies available? What are the methodologies available? Anyone? Okay. So like I will tell you. So methodology one is, you all know this one called waterfall. Waterfall, right? So waterfall methodology, exactly. So I got some good response. So it looks like you got to understand what I'm trying to say, right? Yes, exactly. So spiral, agile, right? RUP. These are what methodologies. So one method is called waterfall methodology, and the other one is called agile, spiral. Sorry, spiral. Even someone says, yes, yeah, white box testing for testing. Yes, that can be possible. So white box, black box, all those testing also going to be the methodology, right? And something we can say, what RUP. So RUP is also a methodology. We can call it as rational unified process, right? So this is what the difference between method and the methodology. So methods are actual steps to achieve a ultimate goal, right? So our ultimate goal is to SDLC. Methods are these four. To achieve this method, there are different methodologies are there, approaches, different approaches, right? So one approach, waterfall method, agile, spiral, RUP, whatever, right? So these are the methodologies we can use to achieve the methods. Sorry, use to achieve a specific goal, right? That goal is SDLC here, right? So, right. So that's about the basic definitions here, right? Now, so we can even go further. We can say why these object-oriented methodologies appear, right? So before this object-oriented analyze and method, most systems were developed using procedural approaches, right? We just discussed about these procedural approaches in the lecture one as well, right? So procedural approach, right? So I know you guys know some object-oriented programming languages, WOP languages, right? So we can say Java, JS. There are huge list of languages, exactly. Python. So everything is what? Object-oriented languages. Something, some languages are called procedural languages. Procedural languages. So for that, we can say examples like C, exactly. So this is what we just learn in our maybe first year to get understanding of the programming, right? So C, uh, Pascal, COBOL, right? So these are what procedural languages. You may not understand the actual difference between OOP and procedural while working on that one. But after you understand the concept of object oriented programming, now you may get the understanding, okay, why we are saying C, Pascal, COBOL, like that languages as the procedural language. Why? Because these languages are, it doesn't have something called class or anything. There's no anything called classes. There's no anything called object. abstraction, inheritance, polymorphism, encapsulation. These methods or these pillars of the object-oriented concept are not exist in C, right? You may use something called struct keyword in the C, right? The struct keyword is going to useful to create some structure in the C, right? But that is actually looks like object oriented, but it's not actually an object oriented concept, because if you know C well, if you learn C in your first year well, you may know the struct keyword is going to use to collect what we call uh, combine more than one attributes, combine more than one attributes, but this struct is not accept any methods. The struct not accept any methods. So if you want to write any method, you have to write the methods outside the struct object, right? So if it is a class, its class should be have a combination of attribute as well as classes, sorry, methods, right? So if you are using struct is only accept attributes, it's not going to accept any methods, right? So that time you have to think these are not the real object oriented programming languages, right? Okay, so this is not our concept actually. So if you understand the procedural, that's okay, right? Now, so why we are saying these things are procedural now? So we know why we are saying these things are object oriented programming, because everything is object based, right? So everything is object based in WOP languages, but in the procedural languages, not everything is based on the objects. In procedural languages, everything is based on functions, right? Not only functions, we can call that as procedures as well. In other words, procedures, right? So for an example, we can say, like for an example, calculate salary. So this is one function, print salary. So this is another function, right? Likewise, it's this C or other procedural language always rely on the functions. The building block of these procedural languages are functions only. Based on the functions, this entire program is running, not like Java or some other object-oriented languages, right? So here the problem is the data was actually separated from the methods. The data was actually separated from the methods, right? So object-oriented methodologies change the focus. The object-oriented methodologies or the object-oriented programming languages, those change this focus. So instead of the functions, right? Instead of these functions, what happen is we are focusing on the objects now. We are focusing on the objects, right? So what are the objects? Maybe for an example, employee, right? So employee, why employee? Maybe these functions, calculate salary, print the salary, all those things are related to the object, employee object, right? Maybe if we are having some methods called study or method called borrow books or something, that may be related to the object called student object, right? Likewise, we are turning the focus from the methods to the objects, from the verbs to the nouns now. Okay, so that time the object became the center of focus. The object become the center of the focus. Now come to the next slide, right? So in this slide, we are going to learn about four major methodologies, four major pioneers, right? So this slide, actually, this is just a summary of what we are going to learn in the upcoming one, right? So we are going to learn about four different methodologies here, right? So methodologies of object-oriented, analyze, and design, right? Four different methodologies. The first methodology is about object-oriented analysis methodology. This is done by two experts, two experts called Code and Jordan, right? So these gentlemen, they create one methodology for what? For object-oriented analysis, you know. So we can actions can be defined like this, like object-oriented analyze and design. First one is object-oriented analyze, and the other one is object-oriented design. Then and only object-oriented programming, right? So this Code and Jordan, these two persons, experts, are propose a methodology that is helpful for the object-oriented analysis. Okay, so likewise, another expert called Grady Booch, he proposed a methodology for the object-oriented design, right? So likewise, there's another expert called James Rumberg. So he produced something called object-oriented modeling technique. We call it as OMT, right? OMT by James Rumberg. And finally, object-oriented software engineering by Jacobson, right? OOSE, right? So what really these things are? I told you before the UML diagram, people are using different methodologies to design or to model their requirement, right? Before the programming, before the coding, people are modeling their requirement. While modeling their requirement, they are using different methodologies, different methodologies. So these are what those different methodologies are, right? So actually, not only these four, there are more than four methodologies were exist. From that, the UML diagrams, UML, Unified Modeling Language, get the best of all these things into the UML, right? Into the UML. But these four are very important one that we need to discuss before learn about the UML diagrams, right? That's the purpose. These methodologies are listed here. Okay, so we are going to learn one by one of what these uh, experts are trying to explain in their methodology proposals, right? Okay, so here you can understand one thing. This experts are explaining concept related to the object-oriented analysis. And this one, he approached something, he give the methodology related to the object-oriented design. And James Rumbeck, he designed something called OMT as a short form, right? Object-oriented modeling techniques, right? OMT. And Jacobson, he introduced something called object-oriented software engineering concept, right? Object-oriented software engineering concept, right? Okay, let's see one by one. The first one is called Code and Jordan methodology, right? So that is what this one, first option, first one from this list, right? Code and Jordan methodology. Okay, so before this, I can give you a short summary of these four. Like for an example, we can say this. I think, yeah. Actually, it's incorrect. The typo, there's a typo. It's not COUD. It should be COAD, right? So code. So code and Yoda. This expert are actually, they find the objects. Find objects. Okay. After them find the objects, the other expert called Booch, Grady Booch, right? He designed the object. Design objects. And then Rumbeck, he modeled the objects. Model the objects. And finally, Jacobson, he did use cases. He did use cases. So use cases, we can say actions. Okay. So these three people are talking about the nouns. Nouns mean objects, but Jacobson actually talking about the actions that is happening in the system, right? Okay, while we are learning about all these four, you can understand what I'm trying to say, right? So first one, code and Jordan methodology, right? So here you can see the main goal. The main goal is to identify the identification of classes and objects, identification of the structure, definition of subject, attribute, and methods, right? So in his method, Code and Jordan methodology, he find, right? He find what? First one is called classes, then objects, and then attributes, right? And then methods, and finally structures. Structures. So this is what the ultimate goal of Code and Jordan methodology. So I told you the Code and Jordan methodology is working on object-oriented analysis part. Object-oriented analysis part. So what it means, he after getting the requirement, we are going to analyze the requirement. We are going to analyze the requirement, and we are going to know what are the classes, what are the objects, what are the attributes, what are the methods, and what are the structures that is going to be play in our system, that's going to be play in our system. So to identify these classes, objects, all those things, we are going to use what? Code and Jordan methodology. I mean, we are not using now. Before the UML come to the game, they people are using Code and Jordan methodology to identify these things, right? Okay. So yeah, okay. So for an example, before we move to the next methodology, for an example, I can say a library system, right? Library system. Okay. So in a library system, what are the requirements? Requirements are, we can say, member borrows books, right? So this is one requirement for the library system. So the second requirement is to, it's about librarian, right? So librarian, he what? He manages the books, right? So member borrow the book, but the librarian manage the book. So what nouns we are seeing here? Nouns. So in this system, what are the nouns we are just seen here? Anyone? Okay. Yeah. So member is a noun, book is a noun. Also, we have librarian. Exactly. So member, librarian, and book. So we can say member, librarian, and book. So these three are, we found out as what? Nouns. Nouns in the requirements, right? Nouns in the requirements. So these nouns are actually what? These are become the candidate classes. Candidate classes, right? So candidate classes means these are having the possibility to become a separate class, right? These are having the possibility to become a separate class in the library system. Okay. Okay. So we found out these are the what? Classes. If we found out the classes, then what next? Then we have to find what are the attributes for each of the classes. For an example, if you take a look on the book, now we have to talk about what the book going to be have, right? If it is a book, book ID will be there, right? Maybe author, right? Year of publication, so we can call it as year, right? So the title also will be there, right? So title. So these are what? These are the attributes. These are the attributes of the book. Likewise, a librarian, if we talk about the librarian maybe have, maybe he is having a name, designation as a librarian, joining date, right? Experience count, maybe 5 years, 10 years, like so. Everyone is having what? Some attributes. Again, we talk about the members. Members also having attributes like if anything, name, registration number, registration date, maybe year of year becoming a member, like 5 years member, 2 year member. Likewise, fines, any fine remaining. These things are what? Attributes of a member, right? So likewise, then what happened? After finding the classes, we find out the attributes. We find out the attributes, right? So after we find out the attributes, we have to find out what are the methods available. What are the methods available, right? So what are the methods available? So again, we talk about the book. The book is having some method called um, issue. Issue mean public, release this book to some member. Some member can borrow this book. And we have something called return book, right? If someone borrow that one, they have to return that one, right? So return book. And we have something called reserve, right? Not only these three, maybe if we uh, go deep into this concept, we will get some more methods as well, right? Not only issue, not only return, not only reserve, right? There are many other methods also available that is related to the book class, right? So we have find out the methodologies. So the next one, so we found out the class, attributes, methods, and the other one is about structure. Structure mean how these classes are organized and connected. So for an example, after find out what are the classes, book, member, and librarian, we have to ask how they are related. How they are related. For an example, we can say a member borrow book. A member borrow the book. So relationship is what? There is a anyhow there will be a kind of a relationship between the member and the book. What's the relationship? Borrowing relationship, right? Likewise, if we find out something, a class called vehicle, but we find out there is two more classes as well, like car and bus. So what now the relationship is? It is kind of a inheritance relationship. You know, vehicle is a parent class. Vehicle is the parent, and those car and the bus will be the child, right? So this kind of relationship also may be available, right? Inheritance relationship, like like that. So this structure is going to help you to focus on the relationship, focus on the connection between the classes, focus on the hierarchy. Hierarchy means the vehicle, car, bus is like having a hierarchy, like so this is general one, this is special one, specialized classes. Likewise, so all these things are what we can find out in the code and Jordan methodologies, right? So this is what we just learned, right? The ultimate goal of this one is to find out what? Classes, objects, attributes, methods, and structures. So all those things were able to find out in this code and Jordan methodology, right? He didn't tell about how you are exactly do this thing. He just tell you if you found out any nouns, that nouns are become the candidate classes, right? The nouns are become the candidate classes. From if you find out the classes, then you can easily find out the attributes. If you find out the attributes, then you can easily define some methods for the each of the classes. If you find out the attributes, methods, and classes and everything, then you can find out the structure. Structure going to tell you what is the relationship between different classes, what is the connection between different classes, right? How they are organized. These things are going to be explained by the structure. Okay, that's about code and Jordan methodology. That's it, right? And the next one, okay, the next one is about, sorry, just give me a moment. There's a glitch. Okay, so then next methodology is called Booch methodology, Grady Booch, right? So his methodology. So in his methodology, we are going to learn about what he is trying to explain, right? So Grady Booch is one of the father of the UML actually. So we can say he is the father of UML, right? He is the father of the UML, right? So why he become famous? Why he become famous? Normally, his focus is all in the design phase. His focus is all in the design phase. Not only design, he just done the analysis like our previous method, Code and Jordan methodology. He is also focusing on the analysis and the Booch methodology. This Grady Booch is also focusing on the analysis. But after analysis, he is mainly or heavily focusing on the design phase, right? So after analyze the objects or after find out the classes and everything, Booch, Grady Booch, he asked, how should these objects work together? How should these objects are work together? So there are different level of thinking. There are different level of thinking. So let's see Grady Booch methodology approaches to software improvement process. So right, so it's about software improvement process. So how improvement? The Booch methodology cover the analysis and design phase of system development. So it's focusing on the analysis as well as design phase of system development, right? He categorized this methodology into two main category. One is called micro development process and the other one is called macro development process, right? So he is always talking about the software improvement process. That software improvement process is divided into two main category. One, he just saying micro development. Other one is macro development, right? So micro means what? Micro means very detailed, right? Detailed view, right? But macro is kind of a big picture, you know. So big picture is going to do what? Is going to tell everything just in the overall way. Overall, this is how you have to do. What's the thing? So he is categorizing the software improvement process into two category. One is about detailed view, very detailedly we have to tell about the thing. Other one is about macro development process. It's about big picture, right? So let's start with the micro development process. Micro means the very detailed plan, right? Very detailed plan. So before learn about this one, let's go with a small example, right? So think of building a house. Building house, right? So if you are going to build a house, there are two perspective. There are two perspective. One is about micro, other one is about macro as per the Grady Booch method, right? So micro and the macro. So let's talk about the macro. Macro is what? The big picture I told you, right? Macro is the big picture. So in the macro, we are going to get some question like, uh, okay, what type of house we are building, right? Maybe one floor or else two floor or 2 BHK, 3 BHK or else a flat roof or what else, right? Kind of what type of house we are building, right? This one. Second one, uh, let's say who will build this, right? Who will build this, right? There may be a lot of architect, lot of experts made there. So who we are going to hand over this project to build, like that question, right? What are the requirements? Maybe, right? What are the requirements. So all these questions can be available in the macro, right? So macro is just talking about the overall as a big picture. What type of house we are going to build, who is going to build this one, what are the requirements to build this house. Those things are going to be talk in the macro category. But so in the other hand, we have something called micro, right? In this micro, we have some detailed works, right? Normally, if it is a house, we have to decide where is the bedroom going to be located, where is the kitchen is going to be located, where is the living room is going to be located, right? So that kind of detailed things, right? So for an example, where is the bedroom, right? So that is one. Second one, let's say how many windows. And third one, maybe how thick is the wall, right? So these are what? These are some detailed view of the house. These are some detailed view of the house. But in the other hand, we have the macro. The macro is the big picture. It's just going to tell you about everything as overall, but not that much of detail. But in the micro, everything is detailed and very accurate decisions will be made in the micro category, right? So now, what is micro development? This is what the micro development is consist of four steps, right? So step number one is to identify the classes. You know, micro means very detailed, right? So we are going to go very deeply here about identify the classes. So we are going to identify if it is a library system, what are the class? Book class, member class, right? Loan, librarian. These are what? Identifying the classes, and we have find out, okay, these are the classes available, right? And the second one is called identify the semantic of classes and objects, right? Semantic. So semantics mean what is meanings and the responsibility, right? So semantic means meanings and responsibilities, right? So yeah, so meanings means semantic and responsibilities. So what this mean is after identify the classes, you have to ask what is a book. Normally, if you find out book, let's say book, librarian, right? So book, librarian, and fine are the classes, right? Now you have to ask some question. What is a book mean? What is a member? Who is a member? What it's mean by fine, right? So identifying the meanings and responsibilities of find out classes. Whatever you found out as classes, you have to identify the meanings and the responsibilities of that identified classes are called as identify the semantic. Okay, so after identify the semantic, what you have to do? You have to identify the relationship. That is the step number three. Identify the relationship of the classes and the objects. So here you can see what is the relationship between a book and the fine, book and the fine, and member and the fine, same, right? And a member and the librarian, right? So these things. So this is where that association is going to be begin, right? So you can understand what type of association, what type of relationship these classes are having between them, right? That one will be uh, explained in the third page. And the final page is about interfaces and implementation, right? So interfaces and implementation means um, so until now, we only know what are the classes, right? Books, members, and loan, right? So we still don't know how they will behave in the software, right? So as a object classes, we know these are the classes we have, and this is the relationship between those classes. But we actually still don't know how they are going to behave in the software wise. So here he is talking about two things. One is called interface, and the other one is called implementation, right? So interface means what? So interface means we can say like, what can this object do? For an example, if it is a ATM system or something, what are the methods? What the ATM system can do? It can allow you to withdraw, deposit, check the balance as well, right? So these are the services that provide by the what ATM. So this is called the interface. Actually, this is called the interface. So why we are calling this one as interface? Because I just write that one, withdraw, right? Withdraw, deposit, right? And check balance. So these are called interface. Why these are interface? Because these are the services that is provided by the ATM system, and we are only telling about the services. We are not telling about the actual business logic. The business logic is not shown here, just the uh, methods that is available in the system are shown here, right? So the implementation, the other hand, this is interface. In the other hand, we have the implementation. This implementation is going to tell you how those services are actually performed internally, how those services are actually performed internally. So that means this these things are actually interface, and the business logic of these things, right? Whatever the business logic, it will be called as implementation, will be called as implementation. So normally for the library system also, we can say there's a method called issue book, right? Issue book method, right? In the issue book method, we have, this is what interface, this is what interface, because it's just telling about the method, it's not telling about the implementation. What about the implementation now? If we are talking about the implementation, we have to write the business logic. Issue book, like if book available, we can say book available, then what? Update the status, update the status. So this is what the real implementation, this portion is the implementation, right? Implementation, and only this portion is called interface, right? So this hide the code in the implementation, right? So this is actually, interface is going to hide the code in the implementation, but the actual implementation is the business logic, right? Okay, so now just about think about a real world example, like a TV remote, right? So you know what are the interfaces? If it is a TV remote, TV remote is having interface. The interfaces are the power button, right? Not only power button, all the buttons in that remote is called as the interfaces. But what is the implementation? The implementation is the electrical circuit, the signal processing, the hardware operation. These are what the actual implementation. Exactly. Yes. Yeah, button circuits are the real interface, and inside the TV, the actual logic is the implementation, right? So okay, so now I would like to stop at this point, right? I'm going to give you a short break of 10 minutes, and after 10 minutes we are going to learn about this macro development environment. Just get a fresh up and come back exactly at 7:17, right? So let's meet again. Okay, students, I hope you all can hear me now. So let's continue this session, right? So almost 10 minutes. So, right. Okay, so I'm going to begin this one from the point where we just left it, right? It's about the second development category called macro development category, right? So we just completed the micro now, and in the micro, it's all talk about detailed explanation, detailed explanation of the system, like identifying the classes, identify the meaning and responsibilities of the classes and the objects, and identify the relationships between the classes and objects, and finally interface and implementation. So in the interface and implementation is going to tell you how these classes and objects are going to be in uh, going to be act in the software implementation part, the real programming part, right? So in that time, the coding, the objects are derived into interfaces and implementation, right? Interfaces are just going to tell you the class methods, right? How it will be there without telling the business logic. The implementation is actual business logic, right? So somewhere we have to show the interfaces, and only somewhere we have to show the implementation as well. So actually, if you take a look on here, it's directly connect you for the encapsulation, right? Encapsulation is binding, is like hiding the implementation and expose the interface only, just like the class. So class is just telling you, okay, we have a class with this name, and these are the some methods, and we are not going to tell you the methods here, right? Likewise, encapsulating, right? Okay, so that's about the micro, and the next one is about macro development. So macro is a big picture. It's a big picture, right? So big picture, here there are some steps are here, right? So these steps are actually it's going to tell you the SDLC. SDLC means software development life cycle, right? SDLC. So here you can see first one is called conceptualization, basic need of the software, right? And the other one, analysis, design, development, and finally maintenance, right? So this is actually the actual root for the SDLC is coming from this macro development environment only, from the Grady Booch. Okay. So here, what conceptualization mean? So conceptualization mean just customer is saying, I need a system. So for an example, we can say I need a online library, right? Online library. That is what actually we call it as conceptualization. The software is not yet ready. We have only requirement. What is the requirement? I need online library. This is what the requirement, and this is still in the concept form. It's not yet implemented. Conceptualization, right? Other one is called analysis. So analysis means after get that what is that requirement, we have to understand the requirement. We have to understand requirement, right? So then designing. Designing means creating the model, right? Creating model. And development. So development means the actual coding, the actual coding. And finally, maintenance. Maintenance means uh, bug fix and enhancement are called as maintenance, right? So here we can say the Booch method consists of the following diagrams, right? So here you can see diagrams. Some diagrams are there, which these diagrams are the diagrams from UML, right? UML diagrams. So normally, as the root for these UML diagrams are coming from this Greedy Booch methodology, right? From the Greedy Booch methodology only, we are getting the diagram, this list of diagram, class diagram, object diagram, state diagram, right? Or else we call it as state machine diagram as well, right? All of these are the coming from Greedy Booj, right? So here you can see in the macro development, we are not talking very deeply here, right? It's just the big picture. Big picture means we are just define the steps here as the overall um, umbrella, kind of umbrella. Inside the umbrella, we have some different steps, right? Those different steps are going to be explained very detailed in the micro development category, right? In the macro, just telling about these are the steps available: conceptualization, analyze the requirement, create the model, coding, and finally bug fix and enhancement, right? That's about the macro development environment, right? And this part, so these all diagrams are actually rooted from this Grady Booj methodology, right? Okay, so the third one is about object-oriented modeling object modeling technique, or else called as OMT, by James Rumbaugh, right? So this methodology is proposed by James Rumbaugh, and what he is trying to tell you is like this OMT, object modeling technique, is used for three steps. Three steps mean one is in the analysis step, we are going to use this OMT. Other one is in the designing step. And finally, in the implementation, the coding step also, we are going to use this OMT method, right? OMT method by James Rumbaugh, right? Okay. So the main idea of the OMT is to, before building the system, we should understand it from the different perspective, right? And then only we can gradually move towards the implementation, right? So without understand the system with from different perspective, we can't go for the actual implementation, right? So the actual implementation in the sense means the coding. Before going to the coding, we have to understand the system from the different perspective, or else different point of view. Okay, so this that is what the golden um, sentence of this OMT, right? So the OMT consists of four phases here, four steps. One is called analysis, other one is system design, then object design, and finally implementation, right? Finally implementation, right? Here you can see the OMT. These are the four steps of the OMT. The first one is called analysis phase, right? So analysis phase mean, so actually this is the first phase in the OMT, right? The purpose of this phase is to understand the problem and the requirement. Understand the problem and requirements, right? So before doing the implementation, we have to understand what the client is telling us. Without understand what the client is telling us, we can't go for the implementation, right? So that's why this phase is used to understand the problem and the requirement. Right. So for an example, if a user comes to you and tell you need a library management system, right? I need a library management system. So to understand the system, this OMT use three models here. OMT use three models. One is called object model, other one is called dynamic model, and finally functional model, right? This object model is also called as static aspects, right? Static aspects. So what object exists in the system is going to be told by this object model, right? You know, it's just telling about the objects. Objects mean whatever the objects available in the system are going to be explained. For an example, object doesn't mean not only objects, it's going to talk about the classes as well, right? So let's say the library management system. Okay, so what are the objects or classes available is going to tell about book is there, member is there, and librarian also there, right? Librarian also there, right? This called static because it shows the structure of the system, right? Even I told you, even if the paper library system is not working, these objects are always there in the library, right? Okay, so static aspect. The other one is about dynamic model, right? Dynamic model, or else the other word behavioral aspect, right? How the system behave over the time. That is what the question is. How the system is behave over the time. So for an example, if we are talking about the book may be available, right? Available in few times, available in few times, maybe the book is issued, right? Issued means someone took that one, borrowed that one, and then finally the book is going to be returned by them. After a few times, the book is going to be returned by them. So this is what this is show the behavior, how the state of the book or how the state of the object or class is changing over the time. That thing is going to be explained by the dynamic model, right? So once you get into the OMT, the first step is to analyze the problem. If you are going to analyze the problem, there are three different models are there. While analyzing, you have to use the object model. The object model used to get the static aspect of the requirement. So for in our example, library management system, in the library management system, the object model going to figure out what are the objects available or else classes available like books, members, and librarian. After find out the objects, the second one is the dynamic model. So this dynamic model is going to tell you what are the behavioral aspects, right? For an example, if we are talking about the book may be available, issued, or returned. So this is going to tell how the state of this book is changing on over the time. Likewise, member may be available, may be discontinue their membership, or else some other actions behavior also they are for the member, right? For the librarian also there are some behaviors. Likewise, the behaviors of the objects and the classes going to be listed out in the dynamic model. And finally, functional model. So functional model is going to tell you what processing is performed. What processing is performed. Processing means the actions, right? So here we can say in the library system, issue book is one process, right? Return book and search book, right? These are what the functions, right? The functions that is in the system. So the functional model going to show the functions performed by the system. Functions performed by the system, right? Then after find out the problem statement, after we find out what are the objects are there, what are the dynamic behavior of the object, and what are the functionalities that is available in the system are going to be understand in the analysis phase. After analysis phase, what we have to do is we have to move to the system design phase. This system design phase. In the system design phase, this is the high level design phase, right? High level design, right? So what going to happen here is going to decide the overall structure of the system, is going to design the overall structure of the system, right? For an example, we can ask some question like what type of system is it? What type of system is it? It's a library management system, right? It's an online system. What architecture will be used? What type of architecture we are going to use for develop the system? That one. What major components are needed, right? All these systems, all these questions are going to be answered by this the system designing phase, right? So that's why this is called as high level design, right? That's why it's called as high level design. Because why we are calling this one as a high level design? Because uh, we are how can say, so we are going to take a look of the entire system. We are going to take a look of the entire system rather than we are focusing on the individual classes, right? We are not talking about individual classes here. We are just telling what type of system it is, what architecture we are going to use, what major components, right? So high level designs are not going to tell you a clear very detailed explanation, right? Low level designs are going to tell you the very detailed explanation. That's why the system designs are called as high level design, right? So after you design your high level design or a system design, you have to move to the object design phase. You have to you move to the object design phase. right? So here we are going to define the objects in the detail, right? So for an example, let's say after everything, now we have find out the objects in the problem statement using the object model, right? Object model. Now what's the use is, using this object design, we are going to refine the classes, right? For an example, student, let's say student is the class. So if student is the class, what are the attributes the student have? For an example, we can say if he is a student, maybe he have something called student ID, he have something called name. Likewise, there are some methods also that is related to the student. What are the methods? uh, Register course, register for the course. This is one method that belongs to the student, and he can view his result as well. So view result, right? Register course, join the course, view result. So these things are what? The uh, methods that belongs to the object called student or else class called student, right? Okay. So at this stage, attributes are identified and methods also identified, right? And the relationship also refined, because we are not talking about the attributes and methods in the previous methods where object model we are just talking about finding the objects. Dynamic models we are talking about the states of the objects. And finally, functions are going to tell what are the action that is available in the system. Now in this object design only, we are organizing everything, right? Okay, we found out one object called student here. For that student object, what are the attributes and what are the actions that is related to the student? Likewise, for the member, what are the attributes and what are the actions? But for the librarian, what are the actions and what are the attributes? Likewise, we are organizing and redefining the classes and the objects in this third phase. Okay. And implementation phase, final one. So here nothing, just the pure coding, right? So convert the design into the coding, right? So the design objects we have developed in here, here this is one design object actually. So this design object is now turned into a coding, turned into a code using any programming languages, normally object oriented programming languages, any of the, right? Maybe Java or whatever, right? So this phase is the actual coding phase, that's it, right? So if we convert this class object into a coding one, how it will be looks like? So I can say like this: class student, right? Class student. This class is having what? Student ID and name, right? So we can say private string student ID, right? This is one attribute. And the other attribute, we can say private string name. This is another attribute. Likewise, we have some methods as well. So what are the methods? Here we just listed there. So what is that? So public void register course. This is one method. And we can have something called public maybe string view result. Likewise, right? So this is how the final coding will be looks like, right? So however, as a system design, finally the code is the output, right? The code is the final output for the system, right? The code is going to decide the project is well done or not done that much of good, right? So if you want to design the code, what you want the actual object design, you want the actual object design. The object, if the object design is incorrect, then the code is also going to be incorrect, right? If you didn't find out the proper attributes and the proper methods for the student class, then what happened? Entire student class is going to be messed up. If the class is messed up, then what happened? Whatever the wherever the class is interacting with the other classes, going to be also messed up, right? So the very important thing is to um, realize your requirement, right? After realizing your requirement, how you can realize the requirement? You have to analyze the requirement. If you analyze the requirement properly, you will realize the problem. So if you realize the problem correctly, then you can do the system design, right? After system design, you can do the object design. So object design only, you are going to design what is your class, what is the object will be looks like. So if it is a object or class, a class should be have some attributes, some methods, and the class name and everything, right? So all those things are finally turn as a coding, turn as the coding. So this is how the object modeling technique is working. This is how the object modeling technique is actually working, right? And final one, let's move to the next one called Jacobson methodology. We call it as OOSE, Object Oriented Software Engineering as well, right? So here, before Jacobson, right? Before Jacobson, here also you can see, before we are going to talk about the Jacobson, everyone is talking about classes. Even OMT, we are just talking about the classes methods, classes objects, Booch method also, classes, classes again, and from the code and Jordan method also again talk about classes everywhere. But here a new expert come called as Jacobson. So his methodology, before he come for the development, developers are focusing on the classes only, right? Developers are focusing on the classes only as the main one. So Jacobson, he asked a question, what does user want, right? The question is, what does user want? What the user want actually? So it means he is uh, thinking the system in a different point of view now, not about the class point of view. He is thinking, okay, if I am the user, I want to interact with the system, I have some expectation, right? So this system should satisfy my these problems, my these expectations. Likewise, what the user actually want from the system, right? This actually do a revolution. This question do a revolution, right? So here we have to talk about something called use cases, right? We have to talk about something called use cases, because of the Jacobson, the use cases were got born, right? Normally, so hereafter we are going to talk use cases, right? So use cases, right? So what is use cases? A use case going to describe the interaction between an actor and a system, right? So I can write that one. Describe the interaction between user or as actor, right, and system. Okay. So describe the interaction between the user and the system. So we call the user, in other words, called actor, right? Whoever interacting with the system are called as actor here, and the system, right? So what does user want? This question going to be answered by the use cases, because use cases are what? These are the actions, describe the interactions between the user and the system. Okay, so now for this use case example, I can give you a scenario called ATM, right? So in a ATM, who is the actor? Actors are always the customers. Customer is the actor. Okay. What are the use cases? Use cases are what the customer, what the actor trying to do with the ATM. So normally the customer not going to order any food from the ATM, right? So they are having some purpose. If if ATM is a system and the actor is the user, between the ATM system and the actor, final actor, customer, there are some actions that is the actor want to perform on the system, right? That system, that actions are called as use cases, right? So do not forget what the use cases hereafter, right? Use cases are the actions. What the action can be do in the ATM system, actor can withdraw money, withdraw money. This is one use case. Other one, he can even deposit, right? Deposit money. Likewise, third one, he can even check for the balance as well. So we can say check balance. So these are use cases that is performed by actors in a ATM system, in a ATM system, right? So with this knowledge, tell me, I will give you a different context now, like university system. In a university system, just tell me who is the actor. Just tell about the primary actor. Who is the primary actor in the university? Not the VC. No, no, no. That's the problem. I just VC is not the actual primary user here, right? The actual actor, primary actor means, okay, we will learn about primary actor, secondary actor, and everything in the upcoming session, right? You will get more understanding of the uh, actor types, right? So normally the main actor, the primary actor of the university is actually students, right? Student. Student is the primary actor. Exactly. Thank you. So here the next one is about use cases. What use cases now? What are the actions the user, the actor can be able to perform in the university? That are what? Use cases, right? He can even eat, right? He can even eat. Eat is also use case, right? Okay. So yeah, okay. Student enroll. I got one use case here called student enroll. Okay, I will tell you the problem here. Student enroll. This student enroll is actually a use case, but this use case is not belongs to the what called uh, the main actor, who the student, because if saying just enroll, that is okay, enroll is acceptable, but student enroll mean this is talking about many students, it is talking about more than one students, right? So student enrollment responsible for the registrar, right? Registrar of the university, right? So this student enrollment is not for the student here. If you say just enroll or else self enrollment, that is acceptable. Okay. So use cases, you can even say exactly. Study also one use case. Great. So study. Okay. Sitting exams. Yes, that's correct. Sitting exams. And what else? Okay. Yeah. Research. Pay fees. Yes. So pay fees. If it is a private university, you have to pay the fees. Research, doing research, right? So these are what some of the use cases. Okay, attending for lectures. Yes, attending lectures is one of the main use case of the lecture student. Playing, yes, playing also. That's also a good use case for the student, right? In the university system, right? I hope now you got understand of what use case is. Okay, great. Right. Just go to the slide now. So here we are going to learn about these five models in the upcoming slide. Just wait. Right. Now use cases, right? Use cases are scenarios for understanding the system requirement. Use cases are scenarios for understand the system requirement. Now you all know in the university system, you told there are many use cases. All those use cases are what? Different type of scenarios, different type of actions that the actor can be performed, right? So based on the scenarios, based on the use case, if you learn about all those use cases, you can easily understand what the system is trying to do, right? What the system is trying to do, right? A use case is an interaction between users and the system. Yes, you all know, right? Users are the actors. The system and the actors, how they are interacting is decided by the use cases. Use cases are the valid reasons one user and the system is interacting between. Okay, so the use case model capture the goal of the user and the responsibilities of the system to its user. The use case model capture the goal of the user, right? So everyone, even if a lecturer, if a lecturer also interact with the university system, the lecturer is also having some goals, right? Based on the goals only, the lecturer is also trying to talk with the university system. Likewise, every actor, whoever interacting with the system, is having a goal. So a use case model capture the goal of the user and the responsibility of the system to its user. Right. Now, um, right, okay. So we are going to learn about this one in the upcoming session, just about use case diagrams, right? So I can skip this one for now. We don't need this one. And here, this is what a use case diagram will be looks like. This is what a use case diagram will be looks like, right? So I told you about someone called actors, right? One actor. He is also one actor, right? So whatever you just write like a sticky human is called actor of the system, actors of the system, right? So there is an unwritten law here for the use case diagrams, right? The unwritten law is, here you can see how many actors, two actors, right? One is called member and the other one is called supplier. Here the main actor, who is the primary actor here, member or supplier for the library system? Member, right? Member, sure, right? Why member? Because of the member, for the reason, for the members only the library is there, not for the supplier, right? The library system is there only to serve for the members, not to serve for the supplier. So whoever uh, the system is depends on is the main actor here, right? The unwritten law here is, if if uh, if you are drawing the UML diagram, the main actor, the primary actor should be on the left side, should be on the left side, and the secondary actors are on the right side. Okay, on the right side. It's unwritten law. Even if you didn't follow this law, it is not incorrect, right? It's also correct while you are drawing the UML use case diagrams, right? It's just an unwritten law. That's it. And okay, that's about the actor. And here you can see there is a rectangle, looks like this, right? This rectangle, the border here, you can see this one with some names here, right? This one is called as system boundary, right? System boundary. So system boundary going to tell you this is our system. Within this, whatever we have our system. Whatever outside this one is not our system. Whatever outside this one is not our system. So here you have to understand one very main thing here. Law is the user, the actors are not a part of the system. Actors are not a part of the system. That's why the actors are always outside the system, always outside the system, right? So supplier is also not a part of the library system, member is also not a part of the library system, even librarian is there, he is also not the part of the library system. Those are actors. Okay, okay, so that is what system boundary, right? In the system boundary, on the top of this one we have written something called library, right? This one is actually the name of the system, name of system. Okay, the name of the system always write on the top, right? Based on this different soft tools that is available to draw the use case diagram, some diagram allow you to write the name of the system on top of the boundary, system boundary, like here, right? Like here, right? This is also somehow correct, but normally, as per the books I have referred, this is the proper way to write the system name, right? The system name should be inside the boundary. Okay, so then here you can see something in the oval shape, eclipse, not eclipse, ellipsis, right? So these oval shape things are called as what? These are called use cases. These are called use cases. Use cases, right? So these use cases are going to tell these are the actions the actor can be able to perform in the system. These are the actions an actor can be able to perform in the system, right? So here you can see, I just erase these things, right? You can see here, um, what is that? Right. So one use case is called checking out books, right? Checking out book. And other one is called getting an interlibrary loan, getting a loan actually. Check out book, getting a loan, doing research, reading books and newspaper, purchasing supplies, right? All these use cases are actually actions, right? The actions are show like this, right? And now what we are doing is we have to link these use cases with the actor. If you find a use case without linking to any of the actor, then that is not a real use case, right? That is not a real use case. If it is a use case, that use case should be always linked to at least one actor, right? At least one actor. Maybe connect with more than one actor also there. If it is a use case, that should be connect with at least one actor, right? Here you can see checking out book. This checking out book is the use case that is belongs to the member. Only member can check out the book, right? So that's why there is a line here, line going like this. That is called association. These lines are called as associations, right? Associations, right? So the associations are going to tell the relationship between the use case and the actor, use case and the actor, right? Getting an library loan, interlibrary loan, right? Who can get the library loan? Only members, right? Again, there's an association. Doing research, only member can doing the research in the library system, right? Okay, reading books and newspaper. Who can do? Member. But here, purchasing supplies. Who can purchase a supply? Member can purchase supply for the library? No, right? He can't do that one. But who can do this one? Only supplier can do that one, purchasing supplies. So that's why there's an association between the use case and the supplier like this. Okay. Uh, just tell me, is this clear for you? Use case diagram. This is actually the basic. We have to go deep into this one as well. Okay. Right. Okay. So now with that one, just go to the next slide. So many methodologies are available to choose from for system development. There are a lot of methodologies are there, right? Jacobson method, Booch method, uh, what else? OMT is there. Like there are a lot of methodologies are there for choose for the system development. Here we look at the methodologies developed by Rumbeck, Booch, Jacobson, which are the origins of the Unified Modeling Language (UML), right? And the base of the UA, Unified. UA is means by unified approach, right? UA is mean by unified approach, right? Unified approach means we are unifying, we are combining different methodologies and bring a final version called as UML diagram. And that UML diagram is actually origin from these gentlemen, Rumbeck, Buch, Jacobsen, right? And there's one more guy also there, right? Okay. So object-oriented software engineering. This one, OOSC, is by who? Jacobsen, right? Jacobsen method, right? So normally this Jacobsen says development is contained 5 models. Development is contained 5 models, right? Those 5 models are, he's saying, these are the models, right? Requirement model, analysis model, design model, implementation model, and testing model, right? Now he is saying, if you are going to do a software engineering, right, the software engine, so I told you what is the software engineering is, right? Software engineering is not about coding. Software engineering is not only coding, right? It's about requirement gathering, designing, implementation, coding, testing, and everything all together. Everything is as a bundle called as software engineering, right? Not only coding. So he is saying, if you are doing a software engineering, that should be contain, that development of the software engineering should contain 5 models. What are those models? First model, he is saying requirement model, right? Requirement model, right? So for an example, just imagine a system called online food ordering system, right? Online food ordering system, right? In this system, the requirement model, right? What is the requirement model? The requirement model is actually the client. Your client is going to tell you what is the requirement, right? So he will just tell you customer orders food. Customer orders food. Okay. So this is what your requirements, right? After you get the requirement is very important, right? After you get the requirement, what you have to do? You have to analyze, right? Analyze the model. What is the what you will be analyzed? You will get the nouns. So maybe customer is there. What you are doing here? You are getting the classes and objects in the system. Customer, order, right? And restaurant, right? So these are what you are analyzing the customer's requirement, right? After analyzing the customer requirement, what you are going to do, you are going to design the classes and the relationship. So you find out the classes here, you are designing the classes and you are designing the relationship between the classes. So relationships as well, right? After everything, what is the next one? What the next one is about implementation. So implementation means the coding, right? So for example, customer means you will create a Java class, customer.java, maybe, right? Is a class, right? Order.java, restaurant.java, likewise. And finally, after implementation, verify the system is working properly. So what the system is going to do? The system requirement is customer order the food, right? So what you have to test here, verify the order creation is success, right? So verifying if the order is creating successfully. That is one big use case of the system, right? Customers order the food. So finally, you have to test the entire system, right? Okay. So as a conclusion, now with that methodologies, right? So we just learn about methodologies, different methodologies, right? So as a summary, first one, I think Jordan or something. Yeah, the first one, the code and Jordan methodology. So what we are doing, we are finding what? We are finding the objects. We are finding the objects of classes, right? Second one, after okay, not after like that. One methodology, that methodology is by Code and Jordan. So in that methodology, we are learning how we can find the objects and classes from the requirement. And another methodology called Booch, right? In this methodology, what we learn how we can design the object, how we can design the objects, right? Third methodology is called OMT, Rumbek, right? This in the OMT, what we learn how we can model the objects, how we can model the objects, right? Here we just learn about implementation, interface, abstraction, and everything. And finally, the OOSC, Object Oriented Software Engineering by Jacobson. So here what we are understanding users through the use cases. So understand users through use cases, right? Understand users through use cases. So finally, as all combined, we got what? We got UML diagrams. We got UML diagrams, right? Okay. So here you can see, okay, is just the part of the use case diagram, right? So in the use case diagram, based on the object-oriented software engineering models, first one is we have to get the requirement, right? That is what requirement model, right? So requirement model, problem domain, and objective diagrams are going to be designed on here, right? It's going to talk about different diagrams, right? For now, we don't need to talk about this one. You can just see use case diagram is going to be based on the object-oriented software engineering approach. We can say first model is requirement model. After, you have to analyze the requirement, then design the model and implement the model. And finally, you have to test the model against the requirements. If the requirements are satisfied by the system, then it's a perfect system. Okay, so and finally, what is the unified approach? UA, right? So the idea behind the unified approach is not to introduce another methodology, right? As we know, UML is not another methodology like a fifth methodology, right? It's not the fifth methodology. Actually, the UML is the combination of 1 plus 2 plus 3 plus 4. That's it, right? Methodology 1, Code and Jordan, Booch methodology. Third one is OMT, and finally Jacobson OOSC, Object Oriented Software Engineering. As a combination of all of these four, we are getting the UML, and UML is not the fifth new methodology, right? It's not like that. It's just a combination. The main motivation here is to combine the best practices right here, the best practices, processes, methodologies, and guidelines along with the UML notations and the diagrams. That's it, right? And so that's all about this lecture slide number 3. Okay, so okay, as we have time, we have to move to the next lecture slide. Just in between that, let me know, do you have any doubts in this lecture number 3? Actually, it's just pure theory. You have to learn about this one because this is history actually, right? So if you know this one, then it's very better. It will be very helpful for us to understand the UML very well, right? That's the reason they include this part here. Okay, so let's move to the next lecture number 4. So in between that, I'm going to give you a 5 minutes break again, right? So just do another fresh up and let's meet around 8:12, right? 8:12 again, sharply.